Let's get started. Yeah, thank you for guys coming. Welcome, and then sorry for making wait, but we'll get started. All right. Last Monday we started the this lecture series, and then last Monday Anthony gave an overview about the how the LLM is do planning and how LLM is good at the planning or not. And this today I'm going to talk about some few example that human can do easily or human enjoy that the problem solving, but LLM is struggling. So people figure out how to tackle the problem. So that's gonna be how we use LLM to do some planning. All right, this is the today's agenda, and then planning. So planning, when I look at the Wikipedia definition, the planning is that it is the process of thinking regarding the activity required to achieve a desired goal. And planning is based on foresight, the fundamental capacity for the mental time travel, and then the evolution of forethought, the capacity to think ahead is considered to have been a prime mover in human evolution, and blah, 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 blah. So yeah, it seems like the planning has to be considered to be unique kind of the capability of the human. But now people saying that we have large language model. When we scale up the language model, LLM is pretty similar to human. Yeah, but in some tasks, LLM shows a very promising result. But and also with that, with the LLM hype and actually the LLM surprising the performance, people use the LLM or some AI model to for planning application. So some companies are making some planner app for travel, and some companies are making some planner for your meal food. Yeah, so I would try to give a shot about the planning, and then let's do that. So we are in LA. Technically, in this time, in this winter season, if you're living in LA, you can do skiing and then surfing in one single day. Technically, it's possible if you're very diligent. So actually, I can ask that the LLM, and then I'm living in Los Angeles. Today is January 11th. I want to do surf and ski in one day tomorrow. Could you give me a plan for me with the timeline? So let me try this one. Okay, and let me see. All right. So yeah, I will have to different one. So this is our playground of our LLM, and then I'm going to test with that same prompt that I used. Then, so I sent to our model, Santa Monica model, and then it will, I guess it will generate the, yeah, here we are. So it said, timeline is that, okay, so tomorrow is January 12th, and then you can do both surfing and skiing in one day. Here's the suggest timeline. 6 a.m. wake up early to make the most of your day, and then 6:30 go to drive to Malibu, and then arrive surfing location takes 1 hour, or yeah, less than 1 hour, and then surfing, and then head back to your car, and then drive to Big Bear Mountain, and then after 2 hours later, then you start skiing, and then yeah, you enjoy ski for 3 hours, and then head back to your car, and then drive back to the Los Angeles, and you can arrive 7:30 without traffic. It will be possible. Yeah, it looks reasonable. And then, all right, let's try. in same, probably same area, but Malibu. When I say I'm living in Malibu, and today is January 1st, 11th, and then blah blah blah, same. And in that case, how does it work? Let me try that. So I reset, and then let me see. Yeah, Malibu. Try that. Yeah. It comes with another plan. Then 6 a.m. wake up early, and then pack your things, and then go to Malibu, and then it takes less than 30 minutes. So it just start surfing, and then 2 hours surfing, and then you take a break, and then now Big Bear Mountain, and then somehow it says the 1 hour. It takes only 1 hour to get the Big Bear, and then anyway, yeah. You can start skiing and then head back to Malibu, and then 30 minutes later you arrive in Malibu, and then you keep surfing again. But when you look at the LLM output, it looks reasonable, but it actually when you actually execute this plan, what LLM give for you, sometimes it's not executable. Yeah, and why is that happening? Yeah, I think the currently when you actually search from website Google, and then Los Angeles surfing and skiing one day, and there's a lot of bunch of article that people actually did that, and then how did they do, and then LLM probably the memorize those articles, and then awesome. Yeah, so it's kind of the extracting your knowledge from the what you have learned from during the training stage, and then it kind of try to approximate that solution with your knowledge, and then so in LA case it was pretty reasonable because it has seen a lot of knowledge. It has seen a lot of the data before. But in Malibu case, it knows that Malibu is pretty close to the LA, so it can tackle the same kind of the planning scenario. But it doesn't actually know how far is from the Malibu to Big Bear, or it doesn't know the environment that how the world works. Yeah, so it was kind of sometimes it mimics the kind of reasonable plan, but it is not correct. So I would say, yeah, LLM is good at retrieving knowledge and approximating answers. That's what I can say. And then instead of the LLM can right away, it can automatically planning. Yeah. All right. And if we go back to definition of planning, then planning is exploration of decides what action need to be taken to achieve a given goal. And then in the case, how we do. So we have goal, and then to achieve that goal, what we do? We come up with a lot of the action, kind of plausible action, and then action 1, action 2, action blah 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 as action n. And then what human do is that we kind of imagine, or we can guess, or we can reason what would be the outcome of each action. And then it requires your some domain knowledge and some reasoning, or sometimes it's imagination as well. And then once you have all the result of the possible action, and then you kind of how does the action is dependent of this action of the result, or other action of the result. And after then you kind of wind up all the kind of sequence of action, and then to achieve the goal. And then finally, yeah, you can kind of make some plan as a human being, and then this is kind of from some very complicated chart for when you start company, like to get the funding. Yeah, you require a lot of this kind of plan. Anyway, this is the how human do, and then now the people, go back to the LLM, and then LLM can do this kind of this planning. In my answer at this moment, it's not there yet, but it's probably it's going there sometime later. But we have to, first we have to figure out what problem can we do we can solve with LLM. So here we are. So I'm going to talk about the game of 24. Have you heard of that? So nobody heard of that. So it's kind of some guys in academia just made up this game of 24. And then so what's the rule? You are given 4 numbers and then find equation to reach 24. That's the game. So here you are. You are given 6, 6, 6, 6 to reach it 24. What should you do? Yeah, some all those 6, right? 6 plus 6 plus 6 plus 6. Yeah, that's 24, right? And how about this?
You don't get to use other numbers, right? No other numbers allowed.
Yeah, only you have to use this number. And then you can use any arbitrary operation like sum, minus, or multiply, divide. Yeah.
You just multiply 4 and 6.
4 and 6, yeah. But you have to use all. You have to use them all. 10 minus 6. Oh, could you say again, please?
And also send
Yeah, probably the 5 times 6 plus 4 minus 10. That would be solution. Probably then, when you tackle this problem, how you're doing? How are you doing? You're kind of pairing each number and then try guess some operation, and then what's the outcome, and then with that, rest of them, how we kind of mix with the other rest of the operation like that to reach the 24, right? That's the kind of what we are doing, our brain is doing. And then, okay, let's try. Can LLM do this? Yeah, so naive approach is like, I gave the prompt and then to LLM, and then use number and base arithmetic operation plus minus times and divide by to obtain 24, and input is 4, 5, 6, 10. In the case, it tried, but it's just this way. Yeah, it's just 4 plus times 6 plus 10 is not 24. It's not 24 at all, and also it doesn't know the answer. It doesn't know how to present the right answer as well. And then, all right, so people sometimes do pre-shot prompt, and so that kind of give that example, and then the LLM can do in-context learning, and then it can follow the rule that what we show in the example. So in this case, in few-shot prompt, it tries some way, but it's not correct. And then, all right, so some people are doing chain of thought prompting. So yeah, you do step by step, and then while the LLM is generating each token, it kind of show their thought process like that. So I try with that, and then in this case, it is not correct, but it's kind of mimicking some example that it has seen, but it's not doing well. So there should be multiple ways to solve this problem, but recently there were tree of thought that was presented NeurIPS last December, so it's kind of 1 month ago. But the paper was already on archive last May. So it has been a while, but it's pretty new idea. So rather than just using just a knife prompting way, it combined with the search algorithm as well, and then also in chain of thought prompt, it still kind of try to ask LLM to step by step, and then you kind of try to encourage the LLM reasoning to reasoning, but there is no kind of the evaluation process. So even though LLM is trying to use their reasoning to approach the goal, but once you go wrong way, you cannot go back, right? That's the autoregressive LLM token generation. So what people does is like, okay, LLM is good at the kind of the generating all the possible action, possible or planning, possible task, possible solution. And then so people try to ask LLM, propose many possible solution, and after that it evaluate, and then it tries to keep the kind of likely or reasonable outcome, and then after that also it also try to propose another solution. In that way, it can kind of get close to the goal. That's our hope. That's the what this paper proposed. So here we are. So when you have the 4, 5, 6, 10, you can ask LLM. Yeah, you can propose many kind of the pairs of the operation, and then its outcome, and then it kind of you can propose 3, and then with some LLM, if you are given left like 6, 9, 10, are you likely to achieve a goal, or are you confident or not? Like validation process, and then you can kind of remove that if that is not possible, and then you keep only the candidate that you think that is possible to achieve the goal. And then in that way, you can keep doing recursively, and then finally you can get to the answer.
So at this step, are you pruning? Like, are you getting rid of those nodes at the first step, or do you like keep generating until you're not gonna really get the answer?
That's a good question. So I mean, you can keep. You don't need to always keep one. You can keep as many as and but if you keep many, and then if the next steps, you are also exploring many child node, and then the complexity will be really huge. And then if you have really good evaluation process, then you can prune the tree very quickly. But if you're not good at evaluating that current node, and then you have to keep exploring. So these guys and then approach it that use the fresh first search, and then also the evaluation process is like very naive. It's not really great, but it's just LLM asks, are you confident with this leftover, and then can you reach the goal, and then likely or say likely or impossible or possible, and then with that, and then it keeps going, and then all right, I tried that way, and then you cannot see that, but with that it actually explored a lot of the child node actually later on, and then finally it was able to get the answer as well, but it took almost 5 minutes to get there. It's actually each token generation process, each candidate generation process, also you are giving few shot chain of thought prompting as well. So generation is really huge. If I kind of do kind of the parallel kind of the LLM inference, then it might be better. But in the case I just sequentially inference. Yeah, so it takes a lot of time. Yeah, but yeah. So this is one of the approach that you can do planning. There is another idea that the have you heard of Voyager paper? Cole, you know that. Yeah. So these guys, what they do is like in Minecraft, I didn't play much on the Minecraft. I'm not expert on that, but in my very few experience that you're allowed to explore many things, and then you can find the tools, and then you can find some resource, and then you can build something, or you can make some weapon, and then you can fight with the other actors that that is against you, and then anyway. So these guys kind of use LLM as a kind of brain, kind of LLM kind of controls all the action, and then also it come up with another strategy as well. With that, so for example, it was able to swim to find some other explore the area that it never have seen, and yeah, it can use some tool as well, and it can catch the fishy, and yeah, it was able to build house as well. So there is no human intervention. There's no human in this process. Yeah.
What is the student feedback?
There might be some human feedback. Might be like if you need window, fix the window, you keep the window like that, and that is just less minimal kind of the feedback, but it's not super kind of supervision. Yeah. Another one is mining wall. Anyway, so in Voyager, what it has is like there's a three kind of critical parts, and then one is the automatic curriculum, and then second one is a skill library, and then third one is the iterative prompting mechanism. So basically, what it does is like it actually the LLM kind of runs the code to make an action in the Minecraft, and then each action has to be programmed, and then with the program, that each action can be added as a skill library, and then like here, then mine wood log, and then make crafting table, craft stone sword like that, or combat zombie as well. So you are kind of first of all the automatic curriculum. Then you're kind of getting some meta information from the Minecraft, and then here is that in nearby there are oak plants, and then in your inventory oak plant is you have stick and crafting table, stone and wooden pickaxe, and then in the case, since you have a wooden pickaxe and then some stones, and it will be beneficial to upgrade your pickaxe to a stone pickaxe for the better efficiency, and then craft one stone pickaxe. Yeah, so upgrade your pickaxe from the wood pickaxe. Yeah. So based on that, this kind of the environmental state, your state, you can figure out what the possible task that is. Then this process is generated by the LLM. Then current state, what should I do, and what task need to be done? Yeah, like that. And then sometimes even when you're hungry, and then your health is then pretty low, and then you have to kill the pig, and then you have to you have to eat some pig. Yeah. This way, yeah, you can explore. You can kind of explore all the tasks that you have to do, and then also what does that is that once you have skill set, you can execute that your skill set, and then as a kind of the programming tool, and then you can keep adding the tool. You can keep adding your new skill whenever you have to, whenever you don't have the skill that previously. And then how it does, it uses some Fuchsia example that you already have seen that, and then you use that, and then you come up with the new programming code to make the skill set. And then sometimes you know that if you generate it one time, it could cause error. So with some iterative feedback, you can give that feedback about the error what you have, and then it can automatically fix the code as well. And then finally you can add the skill set as well. And with that, also you can execute your skill, and then once you execute the skill, you can see what the environment change, and then with that your action is successful or not. And then LLM can kind of the self verification or self evaluation of that your action, and then with that, then you can kind of evaluate this action is good or beneficial, or this is negative, or your exploration like that. With that feedback loop, you can keep learning. And then you can explore more area in the Minecraft your playground, and then also you can keep looking at the new tool, and then you can keep upgrading your new tool like that. Compared to the other kind of the approach like React Reflection AutoGPT, they said that Voyager this way the automatic curriculum, and then adding new skills with the iterative programming, and then self verification. With that, you can explore many tools and it's many areas as well. So that's a kind of the LLM. If LLM can run through your environment and change, and then it can do something very cool, and then it can, without human feedback, you can actually do many things. And but if you can also give some feedback, and then like build some better house like that compared to the previous one like that, and then it can do better. Do you guys have any questions so far? All right. So another approach is that LLM as a tool retriever. This concept is presented by the Meta, and then they said that okay, sometimes if we are given tool that LLM can find what tool to do some task. That's a basic idea. And also, as Anthony presented last lecture, and then LLM can retrieve tool as well, also example and memory and knowledge as well. And then with this retriever concept, then LLM can do very dynamic task as well. And so we last year we experimented this idea. You have you heard of the Secret Santa? In Gridspace, this is our tradition of celebrating our holiday. And then in Secret Santa, if you're participating, every participant has to fill up this form and then questionnaire. Sometimes it's very intimidating questionnaire, like 1 to 10, like that. Like what kind of drink do you like, and then what area do you want to explore, and then what would you hate that if you're given that kind of present like that gift, and then something like that. And then once you know all the survey, and then you're assigned with your receiver, and then we exchange the gift on the day. But this task is very complex because for that you have to know what your receiver's preference, and then to know that always Karen, our coordinator of the Secret Santa, she always send out the form that everyone has to fill out the form, and then Karen has to collect all the answer from them, and then if somebody does not answer, then Karen has to figure out, and then she has to reach out to people. Fill out the form tomorrow is deadline. and then after that, Karen kind of randomly assign people, sender and receiver, and then she send out email to the people. So Karen, I believe that you enjoyed that, but how long did it take when you did this? Yeah.
There was always a risk, I think, last year. I messed up. Yeah.
Yeah, sometimes you have to check your spreadsheet, and then when it's filled or not, it is complete or not, right? And then you have to keep monitoring the spreadsheet, and then this kind of the task is very time-consuming task. Yeah, and so last year we gave the LLM some tool, so it can communicate with people with the SMS, and also it can save the file current state, and then you can look up the what it has been communicating with the people, and also you can search the web as well. And then so whenever people ask, oh, I don't know what this means, and then could you explain this, and then LLM sometimes it try explain as it knows, and also sometimes it search for the query about that people ask, and then you can answer with the search result as well. So this is what we have tried last year, and then let me quickly go over what we have done. So here we gave the LLM very high-level instruction. So please set up Secret Santa for everyone. You can find their phone number from the dictionary directory and ask that following question: drink of choice, or blah blah blah, or the survey of questionnaire, and then make calls in parallel, and for each participant prompt once and wait for the response before any follow-up question, and record their response in a file and keep it updated. And if the response is incomplete, make a new attempt to follow, like that. So we give this high-level instruction, and then LLM start kind of looking at the directory like that, and then we kind of anonymize all our employee name with the Harry Potter character, and then but anyway, it look up all the people's contact number, and then it start reaching out to people parallelly, as you see. And then some people elbows, can you tell Jeremy I'm his Secret Santa? Also, I know you're not spam. And then some people just randomly responded way, and then okay, then who is my sender? Like that. And then, hi Iris, I assure you this is not this is not spam. Secret Santa is being organized confidentially, and I'm here to help coordinate the event. Like so some people, this is very sketchy, and then ask the question, but it assured that this is not scam, and then please do it. And then yeah, and then some people response just partial response, and then whenever it partial response, it tries to keep asking other questionnaire as well to fill the older questionnaire like that. And then some people do this way and this way, and then once you finish the form, then it writes the file and as well, and then and some people ask do I just text you the answer and ask that, and then it kindly give the instruction, yeah, you can text me and like that. And then, oh, this was fun. Can I text you when I'm bored and want to chat? And then I'm glad to enjoy that, Harry. Why I'm here to assist you. And then obviously I'm not able to engage in casual chat, but if you have any task or question, feel free to reach out. And then, but Harry, what can I task you with? And then, and Harry, sometimes I am heading to office, and then how long does it take, like that? And who made you? And then some people keep asking like that, and then but it keeps serving the people. And then sometime later, people fill out the form, and then but in the case there some two guys are hacked, and then Tom didn't fill out the form, then we human intervened, and then yeah, can you follow up the people? And then yeah, it followed up, and then after that it find all the answer, and then it saved all the file into the all the form result as well. And then after that, yeah, it assigned people, sender and receiver, and then after that, it sent out the instruction to how to prepare the gift with each sender's receiver's preference, like that. So it was done by the purely LLM, and then at the time it only took 2 or 3 days to finish this task. And then we only intervened like 2 or 3 times, and we didn't have to keep looking at the form, and then we didn't have to bug the people, and then we didn't have to validation check of all the survey result like that. So yeah, it was very fun experiment. And then we found that when LLM is given some tools, and then it can efficiently find what tool that it has to use to achieve the goal. And then, but probably this is our very preliminary kind of experiment. But I think this way we can do more complicated tasks like that. Yeah. All right. This is some example that I want to share today. And then, do you guys have any question? Is there any question in the audience? MIT people? All right. Then I can give you some exercise. Today exercise in real world, life does always go plan, and how LLM can address this problem when LLM does planning. There's no concrete kind of the given answer, but yeah, you can imagine, or you can use your brain what to do, and then I also have to come up with some idea. Yeah, we'll talk later. And some approach to LLM planning, they kind of list many actions and evaluate them and select. This approach works, but it might require huge computation because the LLM is very expensive as well. Are there any way to reduce this waste of the computation like that? And then can you optimize this process? Yeah. This is our exercise today. And then last lecture, there was a 3 exercise that Anthony has given. And then Anthony, can you talk about that?
Yeah, sure. All right, thank you. All right, so we have 3 exercises on the first lecture of planning. The first question is, hallucinations are a major problem for LLM generations. So what are some strategies for maximizing truthfulness in model outputs? So there are a lot of approaches in the last couple of years that people have developed for dealing with hallucinations. So you can have multiple passes of the LLM, which is kind of a proto chain of thought. You can prompt the generation to only reference source documents or information. You can force the model to cite sources, and you can even, there's been several papers where people literally just told the model not to hallucinate, and that somehow helps. But from the planning perspective, what we talked about last lecture was so recursive prompting strategies like tree of thought or chain of thought, which Wonkyum just showed examples of, can help reduce hallucinations. As Wonkyum showed, by adding a tree of thought, even though it was very slow, he was able to get the model to stop hallucinating answers to his game. Second question is, how might you align an LLM to play a novel abstract strategy game using only description of the rules? So you can get LLMs to play like simple word games or to play games that it has already been exposed to. But in the general case, even if you can get the game to mostly follow the rules of the game, it's not going to be super well equipped to model the state space of the game, and certainly not going to be equipped without some sort of tool or integrated tree search to actually play an abstract strategy game at the level of like a chess engine. And so you couldn't just give it the rules of Settlers of Catan and expect it to play anywhere near a maybe hand-coded Settlers of Catan bot. But in general, general game playing is an unsolved problem. But you kind of see maybe what it would take if you so Wonkyum's Voyager example, for instance, that is not a general game playing system. That is a hand-coded system designed to play Minecraft. But one could imagine using LLMs to generalize some sort of interface between explaining the rules of a game and then designing how it tracks the state space and then eventually plays the game. But again, it's an unsolved problem, so something that I encourage all of you guys to do by next week. Finally, the question is, okay, Stockfish is currently the most powerful chess engine by rating. Based on your own research, how much of this power can be attributed to machine learning versus non-ML algorithms? So there's no LLM in the loop here with Stockfish, but it was meant to show the division of labor between maybe a traditional algorithm and machine learning. This was really meant to encourage you to go out onto the internet and read about Stockfish. But basically, the Stockfish team had been fairly resistant to adding a neural network for many years, partly for compatibility issues, but partly because they thought it was not necessary. But eventually, they relented and added a fairly traditional connected neural network like this that they call NNUE. It is a diagram of it. And NNUE initially added around 20 ELO, but it's now thought to contribute about 100 ELO. So for reference, Stockfish is somewhere around 3,000 ELO. I can't remember its exact ELO now. But if you take away NNUE, which you can easily do and is regularly done as part of their evaluation pipeline, you can probably attribute maybe something like 3 to 5% of its ELO to the neural component, which sounds like a small amount, but when you're talking about competing top chess engines versus each other, it's actually fairly large.
All right, thank you, Anthony. And then, all right, so this is today's lecture, and then we go over some example that we can study some planning perspective of the LLM. And then if you guys have any question or so, feel free to reach out to me, wonkyum@gridspace.com, and then this material will be uploaded to the our website, and then and video will be uploaded to our website as well. And yeah, thank you for joining.
Hello, thank you for calling Gridspace's YouTube channel. Did you make sure they liked the video and smash that subscribe button?
Yes, I did.
And ask them to leave any questions or thoughts in the comments. It helps me a ton. Thank you for watching, and if you'd like to talk to me yourself, go to gridspace.com and click on any one of our demos. Thank you, and talk to you soon.
Thank you, Grace.